Welcome. Today we're talking about nonlinear inequalities, day 2. Basically, we're going to be taking the lesson that we had yesterday and making it a little more difficult. So here we go. I'm going to start with my inequality, and I have 2 square roots. But the first thing I have to do is I have to make sure that the square roots are actually real. So in order for them to be real, they have to be greater than 0, because obviously if it were negative, I would have a number that's inside the square root that would give me an imaginary number. So I'm going to set each inequality greater than or equal to 0, because I can still take the square root of 0, and then I'm just going to solve it. So if I solve it, I'm going to have that y is greater than or equal to -6, and y is greater than or equal to 11/6. So I have to make sure that that's going to be my domain. So I need to make sure that that happens. I can't have a negative number, and I'm only going to be concerned with the larger of the two, because I'm going to be concerned with this one, because if I look at the y being greater than or equal to -6, if I were to take a -5 and place it into this part of the equation, I would end up with an imaginary number. So therefore, I'm going to disregard the y is greater than or equal to -6, and the only part of the domain that I can possibly use is y is greater than or equal to 11/6, because that means it will work in both parts of the inequality. So now that I have my domain, I'm going to solve my inequality. So I'm going to solve my inequality by squaring both sides. So if I square that side and square that side, remember, I'm going to need to FOIL. So when I FOIL, I would end up with what you see there, 12y plus 72 minus 2 times the product of those two radicals, plus 6y minus 11 is greater than 49. And then, of course, I'm just going to add like terms. So you end up with that. And then I'm going to move the 18y and the 61 to the other side. So now I have that product, and since I'm multiplying those two those two radicals, I can put those two quantities under the same radical and just leave it as the product inside the radical sign. And then we're going to keep going because there's not enough room on this page. So here I go. From there, we're going to pick up by taking it and dividing everything by -2. So when I divide by -2, that flips the inequality sign, and that gives me 9y plus 6. And then I still have to get rid of that radical sign, so I'm going to square both sides. So when I square both sides here, I'm going to get rid of the radical. And then when I square the right-hand side, I'm going to have to FOIL. So now I've FOILed and on the right-hand side, and I still have this 2 product of 2 binomials, so I'm going to have to multiply that out. So that's how I get the 72y squared plus 300y minus 792. And I still have to solve it, so I have to move everything over, and I chose to move everything over to the right-hand side, so I would end up with a positive y squared. So then I end up with 9y squared minus 192y plus 828. But then I still have to solve it, so of course I'm going to have to factor. So if I factor, I end up with what you see. So if that's the case, then I'm going to end up with 2 different zeros. The first zero, I'm going to end up with a y, and the y is going to equal 46 over 3. Having problems writing tonight. 46 over 3, and the other one will be y equals 6. So from there, I'm going to have to set up my inequality sign, my number line with my 46 over 3 and 6 on it, and do my sign chart. And I believe that's what that says there. Now, you have your choice. At this point, you want to just take numbers and place them into the inequality, or you could do your terms with it. So you have your choice, whether you want to put it into the original, or if you wanted to put it into the simplified, or if you just want to do it with the factors, which was 3y minus 46 and y minus 6, to find out what the signs are. So you basically can set it up however you want to do. When we do that, we can see that our original equation wanted to know when it was going to be greater than 0, so we want to know where it's going to be positive. So it will be positive here, and it will be positive here. So those are the places where it's positive. So I have from -infinity to 6, and from 46 over 3 to infinity, taking out the negative part, but I have to remember that I had my domain restriction. So since I have my domain restriction, that's going to end up causing a little bit of a difficulty when I create my final answer. So here it is. So I'm going to make sure that I eliminate the numbers that went. I want to go from 11/6 to 6. And then I want to go, because I can't have it be from negative infinity. I can't put in a 0 because that would have given me an imaginary number. So instead of starting at negative infinity, I actually have to start at 11/6. And then I can go to 6, which will give me, that will tell me when it's going to be a positive number. And then I would have the other number that is also going to be positive there. So long process. These problems are not short. They will take a lot of time, but hopefully you can see that it's not that bad. It's just a lot of work for each individual problem. So here's another situation where I'm given a really long problem this time, and I'm going to have to solve it. So in order to solve it, I need to find the zeros. So I would think that the easiest thing to do first would be to take out the greatest common factor, which is C. So now I only have to find 4 other roots. So you know that you have a root of 96, or a number with 96. So now you need to try different factors. So you're going to end up trying all the different factors of 96 divided by all the different factors of 1. So at least that's pretty good. When you do that, you should see that -4 and -6 are both roots. And you would find that by guessing and checking and trying all of the different possibilities. And then when I'm left with, or I guess you could have seen it here, I was left with a quadratic equation down there, x squared, in this case it would be c squared minus 4c plus 4, which that can be factored. So then that gives you your final roots. So then all of your factor forms we would have here for that polynomial is c times c plus 1, or sorry, c plus 4 plus c plus 6 times c minus 2 quantity squared. And I get all my different zeros. So there's my numbers down on my number line, -6, -4, 0, and 2. And as I was saying before, you could pick numbers that you have, like say -5, and you could take the -5 and place that into the original equation and find out what -5 to the 5th is, plus 6c to the negative, it's plus 6 -5 to the 4th, minus 12 -5 to the 3rd, minus 56 -5 times -5 to the 2nd, plus 96 times -5, and you can find out whether that's positive or negative if you'd like. You could also take it and put it into the factored form, or you could take it and put it into all the different factors and do the positive and the negative signs and see if you have an even number of negative signs to make it positive or an odd number to make it negative. You sort of have the choice of how you want to set that up. So once you do that, you're going to see that our original equation wanted to know when it was going to be greater than 0. It will be greater than 0 here, and it will be greater than 0 there. So then I know that my answer will be in between -6 and -4, and 0 and infinity. Notice that they both of these situations can include -6 and -4, because I don't have any situation where it could make it like a negative in the square root, or it couldn't make it a 0 in the denominator. So that means the -6, the -4, and the 0 are all part of my solutions. I also have a greater than or equal to symbol in my original equation. So that's another reason why I know that it's going to be a bracket instead of a parenthesis. So this is my last problem. In my last problem here, I'm given the problem and it's already in factored form. So that's the hardest part right there. So this time I just have many, many, many different roots. So I have c squared, so that means I have a multiplicity of 2 at 0. I have -6, which is going to have a multiplicity of 3. I'm going to have a 4/3, which has a multiplicity of 5, and a c minus 3, which just has a multiplicity of 1. So when I set up my sign chart, it might be easiest in this particular case to actually take the numbers and put the numbers themselves back into the original equation, as opposed to doing all of the different factors. Because if you try to set up the plus or minus for all of these different roots, you're going to have a lot of pluses and minuses going on there. So it would be easier just to substitute it into the equation to find out if you'll get a positive number or a negative number. Once you do that, you get all your different signs, positive, negative, and all that stuff. We want to know when it's going to be less than or equal to 0, so that I know that it's going to be over here and over here. And then I also want to know where it's going to be equal to 0. So although I have this little place that's right in here, I know it's equal to 0 at 0 because that's where I have my 0 there. So I have to include that because I use the -6 because the -6 is here, and I use the 4/3 and I use the 3. They're all boundaries of my intervals where it's negative. But I also have to list where it also could be 0. And the only other place that was not listed in my intervals, which was a 0 or a root, was 0. So that's why I have to put the 0 there. And in that case, the 0 is in set notation because it's just the set of 0. It's no other number. It's not an interval or anything. So I don't need a parenthesis. I don't need a bracket. In this case, I need a brace, which would be the 0. So that tells me it will be negative in between negative infinity and -6. And again, since the less than or equal to, I have a bracket. And then between 4/3 and 3. And again, it includes both of those. And then the last one is just the 0. So there you go. It's a relatively short lesson for tonight. All you're doing is just solving a lot of more difficult problems. We will come back to this the next time I see you and do more of these problems. And hopefully they won't be too challenging because that's the last bit of information that will be on your next quiz. Have a great day. See you next time.